and welcome back. In this video, we will learn how to create kafka-producer and consumer. But before I start, you might want to check my website, czetsuyatech.com. If you want to help the channel, check my Patreon. And if you have any questions about programming, check out my Discord community at czetsuyatech. With that said, let's begin. Apache Kafka is simply another event-driven stream processing conceived to provide high throughput but low latency messaging system. This project demonstrates producing and consuming Kafka messages using Apache Avro, which is a data serialization framework. A random temperature is produced every given time that simulates reading the value from an IoT device. The value is then written on a Kafka topic and read by another service and written on the console. Let's check the project modules. Before we proceed to the project modules, I would like to present a simple diagram about Kafka. Here we have a Kafka cluster, and inside the cluster we have a Kafka topic. On the left side, we have the kafka-producer which push messages to the topic. And on the right side, we have the kafka-consumer which pull messages from the Kafka topic. Now let's take a look at our diagram. This is our project. In the left side, we have the consumer, which is the random temp to Kafka service. And on the right side, we have the Kafka to console service, which is a consumer. And we have some other dependencies or utility projects that we can see in our diagram. The kafka-producer, where we initialize a kafka-producer, and its counterpart, the kafka-consumer. I have created a common project for the configuration files which I named kafka-config, and another one for the model classes, which is the Kafka model, so I can use them among the services which communicate through Kafka. And then finally, we have the Kafka admin. Here, we have defined the creation of topic and some other utilities which we will see later when we dig on each of these projects. You can check out this project from GitHub, github.com/chetsuya lab-kafka-client. You can use any IDE of your choice. Personally, I'm using IntelliJ. And after you clone that project, you should have all these modules inside, as defined in our diagram. So now let's take a look in each of these projects. As I mentioned earlier, random temp to Kafka service is our producer. This is the project that writes messages to the Kafka topic. And if we will check the pom.xml, we will notice that it depends on Kafka admin and Kafka-producer. Kafka-producer depends on Kafka model and Kafka-config. In Kafka-config, we have all our configuration classes for configuring the Kafka cluster, the consumer, producer, the retry, which we will see later, and the Kafka temp to Kafka config data. This is where we store the random temp that we will use later. So we will see that in our application.xml file. Going back to our random temp to Kafka service, the application starts on application.java. Here we will see two classes, the stream initializer and the stream runner. The stream initializer is the one that initialize the Kafka cluster. Here we can see that we have the create topics and check schema registry. This Kafka admin client is defined in our Kafka admin module. It creates the topic if it doesn't exist yet, as we can see here in the do create topics. Now, where do it get the topics that it will create? In the application.yml file. This property, the topic names to create. After we create a topic, it will check the schema registry. So it will issue an HTTP request, and if the response is successful, it will stop the creation of the topic because it's already created and it's already running. As we can see here, we are also using the retry configuration, because after some time, if the cluster is still down, it will not send any messages anymore. And the next class is the stream runner. In the stream runner, we simply mock the generation of a random temperature. For example, it can be an IoT device on the field which measures the temperature. And if for some reason you are monitoring this temperature for a certain degree, and you can issue an alarm if it reach a certain level. This is the start of this class. As we can see here, it will call the simulate random temp stream, and here it will generate a random number which serves as an index to our temps. Temps is actually a value from our random temp to Kafka config data. As we can see here in our application.yml file, these are the values. We have 4 random temp. That's why we randomize an integer value from 0 to the length of the array, the temperature array. And then for each random temperature, we call the random temp Kafka status listener, that on status. But before that, we can see here that it creates a model. This is our model for this service, the temp DTO. Temp DTO just contains the ID, device ID created at, and the temperature. It will call this random temp Kafka status listener. Now let's take a look at the onStatus method. In this class, we can see that first we convert the model from temp DTO to random temp Avro model. Later on, I will show how I generated this class. And then it calls the kafka-producer.send. Now let's take a look at this model. As I've mentioned, I created a common project for the data models, which is the Kafka model. This project depends, or it has dependencies to Apache Avro. And here, I'm using the Avro Maven plugin to read JSON data model classes from the source main resources Avro, as we can see here. And we have the output directory where the Java classes are generated. Again, this is a JSON representation of our data model. All you need to do is define a name and the type. You can check the Avro documentation regarding the data types, but you should remember not to forget to define the namespace, type, and name. Namespace is the package where the Java class will be, or Java classes will be generated. In our case, it's com.czetsuyatech.kafka.avro.model, as we can see here. So this random temp Avro model is generated from this JSON file. And why do we need to do that? So that we can have a common model across our different microservices, so that the conversion of the data from the model in this project to the next service which we will consume that data is synchronized. This is the on status, and here let's check the send. This random temp Kafka producer implementation is defined in our producer project because it's a common project that again we can reuse in our other projects. For example, we have another project that sends another message to another Kafka topic. You can reuse this kafka-producer project because all you have to do is define the Kafka configuration in the service instance application YML file, as well as the producer configuration. Let's go back to our class that sends the message. So it sends the message here, as we can see, and we're using the Kafka template class from the Kafka library. And here we have a callback. What is this callback? Because the return of the Kafka template that send is a future, meaning this is a synchronized operation. So we can wait, or we can use the callback. So once our service, it will call the methods here. Either the message was successfully received, or in on success, or was there an error on failure. Here you can see that I have some logs to understand what happens to the message that we sent to the Kafka topic. And as I mentioned earlier, these configurations are used inside the kafka-producer project. Here in the kafka-producer config, this is our boot up class for the kafka-producer. So we have set these values. The keys is from producer config, as we can see here. So you can populate all or choose the properties that you need in your application. Here I've just used a subset of it, and I set the property in the Kafka config data and Kafka producer config. Again, these classes are located in the Kafka config project, and the values are defined in the random temp to Kafka service application.yml file, because I've added that dependency in this project. So here we can see that I'm connecting, or the bootstrap servers are defined here. The schema registry, this is the topic name, the number of partitions for our Kafka cluster, the replication factor, and this is the producer config. Here we can see that the key that I've used is a long, and the value is of type Avro. That's why I'm using Kafka Avro serializer and some other parameters for the producer. Now let's see it in action. I will try to run Kafka using Docker. So here I have defined a zookeeper, 3 Kafka brokers, and 1 schema registry. So that's why you need Docker installed on your local machine for this exercise. Docker compose up. Now sometimes a broker might not start at all. Normally what I do is check the Docker UI interface and see what services are not running, and I will trigger it manually in here. As we can see here, 3 of the brokers are not running, so I'll just hit start here and all the brokers should run. I'm not really sure why that is the case. Sometimes they run all together. If you have any idea, feel free to add a comment. And now that all our brokers and zookeeper and schema are running, I can run my random temp to Kafka service. So again, this is the one that writes a message to the Kafka topic. And how will we know if this project successfully writes messages to the Kafka topic? We can use the Offsets Explorer. This is a tool for viewing the content of a Kafka topic. So here I'll connect to the lab Kafka client, and we have the 3 brokers which we have defined listed here, and we have our topic, which is the random temp topic. And if we go to the data tab, we can see that there's a lot of data already because I left this earlier. So it seems like it did not run. If that is the case, just build it again. Maybe there was an error, or one of the dependencies not built correctly. As we can see in the log, it successfully connected to our Kafka cluster, and it starts sending message to the Kafka topic in our random temp topic. So remember that in the code that I presented earlier in the random temp to Kafka service, in our runner, it will loop forever while this program is running, and then it will send message to the Kafka topic and sleeping given the configuration we have in our configuration file. Now let's take a look if it's actually writing anything in the Kafka topic. This is our topic. So 49, yes, I think it is sending the message successfully. Now the next project that I would like to present is the Kafka to console service. This project is extending the consumer which is basically the same as our producer. Here we have the bootstrap for the Kafka config, and likewise we have the properties, subset of the properties from the consumer config class, which we have set. Again, these values are defined in our service application.yml file, as we can see here. So this is the Kafka cluster configuration. We have the bootstrap servers, the registry URL key, the schema registry URL, and the rest. And we have our consumer configurations here. Again, this one is important, the key deserializer as well as the value deserializer. And this one, don't forget this one, the Avro key and the reader, which is true, which we have set here. So we're sending these properties to the Kafka consumer that we initialize, which is the Kafka to console service. Now let's take a look at the classes. Again, it starts with the application, and we have our consumer here. So we have the interface Kafka consumer. Here we can see that K extends serializable, so this is the key, and V extends the specific record base. So this is the value. So again, we're calling the Kafka admin client that check topics created. So it's making sure that the Kafka topic is already created on application start. Otherwise, it will create it. And this is the method. So this is the part. This is the class, the random temp Kafka consumer. And this is the method which receives the message, or which pull messages from the Kafka topic, the receive. It is annotated with Kafka listener. It has parameters, which is ID, topics, and group ID. Topics, so this is defined in our application, again in our application.yml file, the topic name. So remember, we have consumer group 1. So we have one consumer inside that consumer group. Later on, I will explain why I'm telling this. So it's receiving a list of messages from the Kafka topic, and we have the keys, partitions, and the Kafka offset. Now let's try running this application. The random, or the Kafka to console service B1, and it should receive all the messages that it haven't received yet, as we can see in here. So it received, first it connects to our Kafka cluster, and it read 35 new messages. Now let's take a look at our random temp to Kafka service. It's still writing messages to the Kafka topic. So this is the device ID 2994, and if we will check here the device ID 2994, we have received it. So our Kafka to console service 1 successfully pulled the message from the Kafka topic. Now what's this other project, the Kafka to console service V2? If you will remember, the consumer configurations are defined in the application.yml file, but I'm using my own custom configuration name. Now, Spring provides its own Kafka configuration like this, but some of the properties are still missing. So if you want, you can use this kind of configuration, Spring Kafka. So this is already defined. They have provided some of the most commonly used properties, and it will automatically configure your Kafka factory, as we can see here. So this is the configuration, this is the bootstrap, this is the factory which creates the concurrent Kafka listener container factory. As you can see, I have not defined the properties similar to what I did in the Kafka consumer, like this one. So this is very verbose. In our second version, it's very simple because the configurations are defined in our application.yml file. Now let's try running this application. Actually, it's similar to the first one. The only difference is the Kafka bootstrap class. So this one is for the backup config. As I explained earlier, it will send a message. If the Kafka cluster is down, it will wait for a delay and it will try to resend the message again. And it will stop after an n number of tries. One thing to remember is that we're using this Kafka JSON listener container factory bin in our Kafka listener annotated method. You can see here, container factory. So one thing that you will notice is that I have defined the group ID here, which is 2. So I should not define this, right? So if I remove this and run the Kafka to console service v2, it should run on kafka-consumer group 2 like this. So let's try running the v2 of the consumer service. Since we're running on consumer group 2, it should pull the messages from the Kafka topic successfully, as we can see here. But one thing that I don't understand is that the group ID is random temp topic listener. So why is that the case? I mean, in the application.yml file, we have defined the group ID, but it's not using that. That's why if you encounter the same error, you should define the group ID here. So what's the problem with that? The problem is that if you have, as I mentioned earlier, if you have the same group ID as the first consumer, for example, you did not set the group ID here and you have 2 services, it might use the same, and you have the same code, it might use, or it might set the same group ID. And what will happen is that the second service, which uses the same group ID, will not be able to read the message, as we can see here, because this one is using the group ID consumer group 1. As we can see in the v1, it continuously pull messages from the Kafka topic, like that one. But the second service is not pulling any messages. Why is that? It's because a Kafka topic partition can only be assigned to one consumer in a consumer group. Meaning, if you want 2 consumers, so if you have, for example, you want, or there are 2 services which should read message from the same partition, from the same topic, both of them, or each of them, should have or should be defined with their own consumer group. Now let's try resetting the consumer group value for the v2, and again let's set it to 2. And if we run this service, we should be able to pull messages again from the Kafka topic, like that. And that's the end for this demonstration. I hope you learned something from this video. If you're also working as a programmer, don't forget to subscribe to my channel and hit the bell icon, as I upload programming related videos every now and then, which might be helpful to you. Thank you for watching, and see you on the next one.